In this video, we're going to talk about errors in sampling. So any error that takes place in the sampling itself, that's called a sampling error. There are such things as non-sampling errors, things that didn't arise, errors that didn't happen because of the sample or the process of sample. Those would be non-sampling errors. So let's look at sampling errors. Now, as a rule, the larger the sample, the smaller the sampling error, because sometimes the size of the sample makes up for any error that might occur. In statistics, a sampling bias is created when a sample is collected from a population and some members of the population are not as likely to be chosen as others. So that's a problem. It's like not having that random element where people are equally likely have a chance of being chosen. So when it happens, incorrect conclusions can be studied. So what that really boils down to is the sample doesn't represent the population. That's what that means. So our sample is somehow not really looking like the population is, and that becomes a problem. So as we kind of go through each of these, we'll reinforce that idea and add a few others to it. So this first one here, problems with samples, a sample must be representative of the population. Representative of the population. A sample that is not representative of the population is biased. And that's a problem because when something is biased, your results are thrown out. Nobody's going to take you seriously. Self-selected samples, so responses only by people who choose to respond, such as Collins surveys, are often unreliable. So we can't rely on those results to really represent the entire population. Self-selecting is a problem. Sample size issues. Samples that are too small may be unreliable as well. Larger samples are better if possible. Sometimes it's not possible. At a small school like OCCC, our samples are going to be small because our population is small. So we just have to work with that. Sometimes we can't get away from it. Another example is when you're doing crash tests with cars or looking at rare medical conditions. Those things, you're not looking at large populations. So you're going to have to work with small samples. Okay. Undue influence. So this is collecting data or asking questions in a way that influences the response. So you don't want to somehow lead people into a certain response. That's a problem with your sample. Your data is now contaminated. All right. Non-response. Non-response or refusal of a subject to participate. That's another problem because then if somehow it's not enough for people to want to participate, you might be getting strong responses, and that's not going to be representative of the population. Causality, a relationship between two variables, does not mean that one causes the other. They may be related, or they call that correlated, because of their relationship through a different variable. So it's possible that you kind of get a relationship that's not really there. It looks like it is, but it's not really there. Self-funded studies are always a problem because it's always hard to know if they're impartial. And therefore, you have to kind of really make certain that the study is done well and somehow they've managed to keep it impartial. But it does kind of become a problem and people tend to question it. Misleading use of the data. So this is improperly displayed graphs. Improperly displayed graphs. So if we do a graph that just isn't like complete or lacks context or somehow just is kind of weird in the way it's displayed or confusing, that's a problem. That's misleading. And then confounding is when some responses cannot be separated. So that makes it hard to draw conclusions when all of a sudden you realize that there was something maybe you didn't consider that popped up during a study. Like if you're studying if exercise helps people lose weight and you realize that people who are exercising are also eating well, that's confounding because maybe it's the two things together. So is one causing it? Is both causing it? Is the other one causing it? That's a problem in a lot of studies. Okay, so let's look at these examples and see if they are going to result in good samples or not. So define the average GPA of students in a university. All honor students at the university are sampled. That's not going to work because we're looking at honor students. So that's not going to be representative of the population. This is a special group of students. Maybe they're full time. Maybe they're extremely high IQs. Who knows, right? Maybe they have parents who are pushing them and they're under a great deal of stress. These may not be good representations of everybody's GPA. To find the most popular cereal among young people under the age of 10, stand outside a large supermarket for 3 hours and speak to every 20th child under the age of 10 who enters the supermarket. That's good. The 20th, this is going to be a group of people who are random because you're counting off. You're looking and asking the children. It's a simple question. You're probably going to get responses. So you're not going to probably suffer from non response. And yeah, it's using a sampling technique that keeps the random element. To find the average income or annual income of all adults in the United States, sample US congressmen, create a cluster sample by state considering a stratum. Okay, wow. It doesn't matter that they've used a good sample. The fact that they're asking the US congressman is the problem because a congressman typically makes more than $100,000 a year. And that's already above what the annual income is for United States citizens. So this is just not a good one because the group they're looking at is already in the upper income bracket. To determine the proportion of people taking public transportation to work, survey 20 people in New York. Conduct the survey by sitting in Central Park on a bench and interviewing every person who sits next to you. No, this is not random either. What if you're a female and therefore more men sit next to you? What if you're a male and women don't want to sit next to you? I don't know. What if you're intimidating looking because you're staring at them, wondering if they're going to sit next to you? There's a lot of problems with who's going to sit next to you. Are these people sitting next to you because they have to rest and therefore they're out of shape? There's so many reasons as to why that's not good. So the minute we're allowing people to self-select, it's not representative of the population. Determine the average cost of a 2-day stay in the hospital in Massachusetts. Survey 100 hospitals using a simple random sample. Yep, that works. That's a good technique. Using a simple random sample, we're going to ask all the people in the hospitals about their 2-day stays in Massachusetts. That's excellent. That's a great sampling method.